Hello everybody, in this video we are going to continue solving another problem live from LeetCode's top interview 150 problem list. So far we have solved all the problems up to substring with concatenation of all words. If you haven't checked out my videos on those problems, please go to my channel and check them out. Today we are going to pick the next one, which is minimum window substring. This problem is classified as hard difficulty level. Okay, so let's read the problem and make sure we understand it. Given two strings S and T of lengths M and N respectively, return the minimum window substring of S. Okay, minimum window substring of S such that every character in T, including duplicates, is included in the window. Okay, if there is no such substring, return the empty string. I think I understand the problem. It's just the window word threw me off a little bit, but I think what they mean is given a string S and a string T, we are basically trying to find the shortest substring in S that contains all the letters in T, right? So let's look at the examples and make sure that's the right understanding. The test cases will be generated such that the answer is unique. Okay, I'm not sure if that's really helpful. But okay, so they've given that information in case it is. Okay, so in this case, S is ADOB, Adobe Code Band C, something like that. And then T is ABC. So yeah, the smallest or the shortest substring of S, which contains all of the letters from T, which is A, B, and C, is these four letters B, A, and C, right? So in this case, we return B, A, and C. And if there were two A's in here, if there was A, B, C, A, then we have to find the shortest substring that contains two A's, one B, and one C, because they have said including duplicates, right? Let's look at the second example. S is A, T is A. So yeah, the whole string S is the minimum substring that contains all the letters in T, which is only one letter. So that's obvious. In this case, S is A, T is A. The output is empty because yeah, there is no substring in S which contains AA. In this case, actually S is shorter than T, so there is actually right away it tells us that there is no answer. But even if S was something like ABC, for example, and T was AA, the answer would still be empty string. Okay, so that makes sense. Let's look at the constraints. So M is S dot length, N is T dot length. M and N are between 1 and 100,000 inclusive, okay. And S and T consist of upper and lowercase English letters, okay. That makes sense. Follow-up, could you find an algorithm that runs in O of M plus N time, where M and N are the lengths of the two strings? Basically, the follow-up is, can we find an algorithm that runs in linear time, right? That's what M plus N means when two strings of M and N length are given to us. Anyway, we'll see. Maybe we can, maybe we can't, but we'll at least first try to come up with an approach. So let's take this example. Like I always mention in such cases, there is always a brute force approach, right? Which is, let's take all the substrings of S, right? And check for each of those substrings whether it contains all the characters in T, right? And take the smallest of them. We have done on this channel, we have implemented such brute force approaches just to compare with a better approach quite a few times, so we are not going to waste our time on that. Plus, they have already given a follow-up which tells us that there is a better approach, right? So we'll try to do that. So let's see. Well, I mean, one thing I thought about, and it's kind of a big hint, or maybe not that big of a hint, and even if it wasn't there, maybe we would have figured out, but not sure how quickly, is that in the problem we just did before this problem, which is substring with concatenation of all words, we actually did it by two approaches, and I've uploaded videos on both those approaches recently, so please check them out. We actually did a technique which might be useful here. And in fact, this is basically under a category called sliding window. So that also gives me a hint that, some sort of a uh, window into S that we keep on changing based on some criteria might help, right? So in the previous problem, substring with concatenation of all words, we did something where we took the window of words into a specific thing, and then we were basically trying to change the window based on certain properties. So I think some approach like that is what I think could work here or will work here. So let's say the window initially is defined by left is 0 and right is 0, right? That means it defines the substring inclusive of left and right indices, which means substring is which means S of substring is, just A, right? And we say, okay, does that contain all the characters? No, so increment right to expand our window, right? We are making our window bigger. And so similarly, we say, okay, now we incremented right. So we say, hey, this is 1, then what does that correspond to string? AD, it indicates that string. It still doesn't contain all of A, B, and C, so we still increment right. So then we keep on going, we say ADO, we still no. I'm just going to keep on going a little bit faster. 3, ADOB, actually, and then ADOBE, DOBE, still doesn't contain all of A, B, and C, just ABE. We still haven't figured out how are we going to efficiently check that, but I think some sort of a hash map should actually help us there. But let's at least look over the core algorithm, right? ADOBEC. Okay. So finally we have all of them. So yes. So we just, when we get it, we just basically increment our best shortest string so far, right? So update shortest string or substring to ADOBEC, right? Because that's the first one we found and there is no better one. So right now that's that. Okay. Now, since that happened, we are going to try to shrink it from the, actually, do we have to shrink it? Can we keep on going? Like, can we do L equals 0 or equals 6? And then, no, actually, wait. So I think it's better to shrink because consider this example where we have a leading X, right? So in this case, this thing will be X, A0, etc., right? So in this case, we should actually try to shrink it from the left side. In fact, yeah, I think we should actually shrink it in a loop. Okay, so this is interesting. So when we get a yes, we do multiple things in a loop, right? So we say, first you basically update the shortest string in a loop. One second, the loop, and inside the loop we update the shortest substring to this, which is just a substring of L comma R, right? Like wherever that is. But then we decrement left if we can, right? So decrement, and what do you mean by if we can? Decrement left, and the loop will be until we one second, loop until we can peel off left characters. And what I mean is, so for example, if this was not just one character, if this was XYZ, right, then we can actually peel off 3 characters from the left side to get a shorter string, right? So we can peel off whenever, as soon as we drop below the desired count, right? So there were 3 characters to match. And yeah, so we can decrement until we reach left reaches D, I think. Yeah. So, and that's because we already would update ADOBEC to be the shorter one. So initially it will be XYZ. So this part is interesting. I know it's become a little bit more complicated than before, but I think it is important to get this part right. So decrement left, and then yeah, this we have to convert to some code condition which stops at some point and decrement until we can peel off left characters, right? Actually, let's figure out what that condition would be. I think we have to keep some match count to do this, right? Like to figure out how many characters matched. And if that match count reaches equal to 3 in this case, which is t dot length, then that is how we will know this is a yes, right? So the way this becomes a yes is some match count has become equal to t dot length, right? And here we will basically decrement left until match count equal t dot length, right? So because we would only decrement the match count when we see a character inside T, right? We wouldn't decrement match count with X because that is not A, B, or C, not Y, not C. And finally at A, we will decrement match count from 3 to 2 because we are removing one character, and that is okay. So I think that will work, right? And then here, hence the left has become, oh, sorry, this is not decrement left. I meant increment left. Sorry, we are peeling off characters, so I thought about decrementing. Well, it's incrementing the left pointer. So ultimately here the left pointer would point to 0, 1, 2, 3, 4, right? Because it will be pointing to A here, sorry, D here, and that is 4, right? And then R is 0, 1, 2, 3, 4, 5. Okay, so these won't be 0, 1, 2, 3, 4, 5. Here I will be at 3, 4, 5, 6, 7, 8, right? And so R is still 8, and SS would at this point be DOBEC, right? DOBEC. And that, does it contain all the characters? No, it doesn't. And so we increment right. Correct? And similarly, we keep on going. So I think I don't have to do the whole thing, except that I do want to see how the best answer in this case would be found, right? Which is still B, A, and C. This was still X, Y, Z at the beginning. X, Y, Z, right? So let's see, Adobe Code Band C. Okay, so I am at CO here, CO 4,9. And then similarly, I'll keep on going to COD, CODE, and CODEB. Still not done, and CODEBA, right? So this is where I think we will get, actually we will get one match here, CODEB, right? So, and this will be equal to 9, 10, 11, 12, 13, right? Is it 4,13? That should be 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I think so. Okay, so so BA actually, that would be for 13. Yes, and that contains all the characters. If you look at it again, well, it contains an extra B, but this is why peeling from the left is important, right? So again, we loop through this. Loop until match count, and match count at this point would be how much? Like match count would be 3, right? And yeah, so we would be doing that, and until substring, we will be updating this to the shortest one, but we'll be incrementing left. And how many times will you do it? Well, we'll peel off D, O, B, and B wouldn't affect the match count because match count is still there. Another E, and then finally code BA will become our, here finally the shortest string or substring rather will be set to code BA, right? That contains, and that is 6 characters. The initial one, this one was longer than 6. Well, in this case, actually, it would be set to Adobe C. That is also 6 characters. So it won't update, but at least it found another match, right? And left would be set to, by incrementing a few times, it will be set to the character after C, so O, and this was 4, so 5, 6, 7, 8, 9. So left will be set to 9, right? So left is 9, and right would be set to 13. That's actually just 5 characters, not 4. Yeah, and that is fine because we will be considering ODEBA after that substring. Yeah. So I think that's the algorithm, right? We basically keep on changing the window and keep track of whether we have seen all the characters in T. And as soon as we figure out that we have seen all the characters in T, that is when we basically try to peel off from the left side and update our best shortest string, right? Okay, now the part to figure out is how do we keep track of whether we have seen all the characters in T? Well, I mean, like the previous problem, we can create a character map which has all the character frequencies in T, and then try to decrement that and see if everything becomes zero, right? And we can also, yeah, so we can keep a track of the count of the characters as well, just to quickly figure out the count of the characters that match would just be like to not have to sum that hash map every time, the sum the values of hash map in every time. So that is what we'll do. I think at this point I know enough to yeah, I want to actually, one thing is that in this case, since they have given us the fact that is all uppercase and lowercase English letters is the only characters in the string, we don't even have to do a hash map. We can do an array where we use the ASCII value of the characters as the index into the array, or ASCII value minus capital A, right? Because that's the smallest. So for folks who probably are not familiar with ASCII codes, like capital A, among all the letters, at least English letters, capital A as the lowest ASCII code. I think it's 65, if I'm not mistaken. And then it goes up to Z consecutively. I don't remember if there is anything in the middle between that and small a. I think they are contiguous, but doesn't matter. We won't really have to know that knowledge. But we do need to know that A is capital A is the smallest, and small z is the largest ASCII value, right? Largest ASCII value in among these things, right? So what we can do is, instead of doing a hash map here, which will be a word frequency map, we can actually return an array, so build char map or something, and it gets a string and it will create a yeah, so that's good. So let's do that. We need an array. What will be the size of the array? Yeah, actually, so the size of the array can be z minus, I think Java allows very much like C this kind of operations, right? Subtracting two characters will give you the difference between the ASCII value of those characters. So I think we can do this, right? And that is the size of the array we need. Oh, we need +1. Is it 1 second? Yeah, we need +1, right? So let me think about it. If A is 65, or let's say A is 10, just for simplicity, then this would be, or 11 rather. Actually, if A is 1, then this would be 26. So yeah, that would be 26 minus 1. So I want +1 there. Yes. Okay. So that's our char map size. And now what do we do is we say for int I equal to 0, I less than t dot length plus I, and we want to get the index into this array for the character, and the index will be basically int ch index equals t dot char at I minus capital A, because capital A will go into the 0th slot of the array, capital B will go in the first slot, so this will give us a nice index into that array. And then we just say char map of ch index plus plus, and Java already initializes all the array cells to 0, so it would start with 0, right? So that's that, and we return char. Okay, so that's our helper to actually create a frequency map. So let's use that helper. Char map equals build char map and t. Okay, so that's done. Now what do we do? Well, we have that algorithm of left, right, and so on. So once again, I'm gonna take this up here because I need this algorithm to kind of make sure that, okay. Okay, so let's kind of look at this algorithm. So first we want left to start with 0 and right to start with 0, correct? Then we are going to keep track of best or shortest or min left and equal to 0, I guess, and min size or min sub. This is the minimum left of the, this is the left of the substring, that is the shortest one, right? And min length equal to 0. Actually, yeah, I think, no, length can be s dot length plus 1, because when we find a better length of the substring, we want to find minimum, so we should set it to a bigger value. And in this case, we don't have to do integer dot max value. We can do s dot length plus 1, because there won't be any substring bigger than s dot length, right? Okay, so that's that. Then what? Okay, then we do while right is less than s dot length, right? Because we are just keep on moving right to expand our window, and then left, we trim from the left side once we have found all the characters, right? Okay, so that's that. Let's say int, wait, no, not int, char ch equals s dot char at, right? That is the character, and we get the index of that character from the array in the frequency array, right? That is the, actually I don't want to copy paste this logic, so even though it's very, very simple, I'm going to do this. I wait and get char index, sorry, char ch, right? And we say this. One second, you'll see what I'm doing here. So we are going to just use that helper here. Actually, yeah, get char index t dot char at I, right? Yeah, okay. So the reason is because I need the same logic here, so that's why I did that. Okay, so we say int ch index equal to get char index ch. Okay, so actually if I'm doing that, I really don't need this. Sorry about that. I mean, just live coding, this is always fun stuff, right? Anyway, so we got the ch index, that is the index of this character into the frequency map, right? Now there are two types of characters, right? Characters which exist in T and characters which do not exist in T. So I wonder if we should only, well, I mean, the frequency map, the char map is large enough to hold character accounts of any character, not just the characters in T, right? Because it's all the alphabet characters, English alphabet characters. So the thing I'm trying to figure out is whether we should only whether we should check if this character is one of the characters in T, or can we actually just decrement the count of all the characters and let them go to negative, right? So for example, if T was ABC, then the char map would contain A appears one time, B appears one time, actually those are capital, C appears once, and then it will say, hey, D appears 0, and so on, right? In fact, it's an array, right? So sorry about that. Even it will actually be an array of 1 comma 1. It's not a map, I forgot again. 1 comma 1 comma 1, and then rest will be 0, right? So 0 comma 0 comma dot 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 dot. So if this character, right, is not one of the characters in T, the corresponding value in the array will be 0. So decrementing that will make it negative, and I think that is okay. We can just let it be. We don't have to really check if it is one of the characters in the string T. So let's try that, and if it doesn't work, I'll modify it. So let's say int, actually minus c char map of ch index, right? Because we want to decrement that we already saw that character once, right? So if T was ABC and we saw 1A in S, then we want to decrement its count, saying we don't need that many anymore, right? We need one less. Okay, so we can do that. And then we say, if it becomes 0, well, actually, that doesn't matter if it becomes 0. Okay, so how do we figure out we have found out all the characters of T, right? And I think for that, I did mention this when I was thinking about the algorithm, but I didn't do it. We need a count of how many characters in T we have seen, right? So we say int um, um, remaining match count equal to T dot length. That is how many we need to match. And now here we have to be careful, right? We don't want to be decrementing that for a character that does not exist in T. We only want to be decrementing that for a character that does exist in T, right? So we say if, oh, so this is actually important. We should let the others go to negative, because otherwise there's no way to figure out which characters are the ones that exist in T and which ones do not, right? So we say, one sec, let me think about this. Actually, I can just ch count. If ch count is greater or equal to 0, right? After decrementing, if it is greater or equal to 0, yes, then because the character that does not exist in T would already have gone to negative, right? So if the count of that is still greater or equal to 0, then that is a character in T. In that case, since we have seen one, we will actually decrement the remaining match counter. So that's what we'll do. Yeah, I think so. And yes. And if remaining match count becomes 0, if remaining match count equals 0, that is when we have to do the trim. Remaining match count 0 means we've matched everything, right? If there were 3 characters in T, we found all of them at this after this character. After the character at right, we found all of them, right? And at that is when we do our trimming algorithm from the left, right? Like we loop until, yeah, actually in this case, instead of an if, we can just write a while loop, right? While it is 0. And you'll see why in a minute. Like I just, yeah, you'll see why in a minute. So while it is 0, we first figure out what is the length of the substring we found, and if it is a better, shorter substring than what we have found so far, right? Because we remember we have matched all the characters in T. So how do we do that? Well, we say int substring length equal to right. Right is not incremented yet. So right minus left plus 1, right? Because it's inclusive of right. Yeah, so it should be right minus left plus 1. Plus 1 is important. And int, actually no, not int. If substring length is less than min length, right? Was it min length? Yeah, it's min length. Then we say min length equals substring length and min left equals left, correct? And otherwise, yeah, I think that is good. Okay, so first we did that. Now we try to peel off one character from the left side, right? This is just checking whether the substring we found is shorter than the best one we have so far. This entire 5 lines of, or 4 lines of code, 5 lines of code is that, right? We still haven't peeled off from the left if we can, right? And that's what I want to figure out what to do. So, okay, so what we do is we take the left character, ch on the left side equal to s dot char at left, that's the left character, and we get its index in the index map, right? So left ch index equals, actually I can do the same I did earlier. I don't need a separate character because we are not going to use the character later. Get char index and that, right? So we are getting the index where in the array where the frequency or the count of that character is, and we are going to, okay, so here is where we need to figure out whether this is yeah, so what we need to figure out is if the character we're peeling from the left side, is it one of the characters which is in the in the T string or not. If it is not in the T string, we should not decrement the match count, right? Actually, I just noticed a typo there. And if it is in the T, then we have to. And the way we will figure it out is if yeah, okay, I think this is how, right? So left ch count equals, we want the count before we decrement it. We will always decrement the count, but before we decrement it. So we are going to read it, which is char map of left ch index, and then we will do char map of left ch index minus minus, right? We are going to, actually we can just do a post decrement operator here. So it means we are going to read the value from that index first into left ch count, and then we are going to decrement it. We always decrement it, but if left ch count was 0 and then it went below 0, then that means we actually removed one of the characters in T, right, from the left side, and that's when we decrement remaining match count, right? Is that true? Yeah, I think so. I think that makes sense. And because we already did this, the reason I was thinking whether that is true is whether we need to do this after this minus minus or before. And we need to do before, not after, because we would be peeling off one character, one extra character from the left side. And so when the match count actually, oh wait, and this is not minus minus. The remaining match count is plus plus, right? Not minus minus. I'm getting those plus pluses and minus minuses reversed in my head. And oh, and we need to increment left. I completely forgot about that. So we need to increment left. That is the way we peel off from the left side by incrementing left. At this point, it's safe to increment left because, you know, I mean, I could do plus plus here as well, just like I did minus minus here. But in this case, I'm going to keep it there. It's too buried there in my, anyway, it doesn't matter. Okay. So, and then finally, we say return, well, if we never found anything, then min length will be equal to this, right? If we found something, then min length will be, okay. So if min length is less or equal to s dot length, right? Then we found a proper substring. In that case, we return, actually return is already there, s dot substring of left comma, sorry, best left, not left, best left comma best left plus best length, right? Yes, I think so. Yep. And otherwise, so this is not a colon, it's a question mark. Sorry, I'm using ternary operator. I'm getting confused myself. Otherwise, we return empty string, right? Okay, wow, that is a lot of stuff. So let me take the example and kind of just run through a couple of iterations just to get an intuitive sense that the code is working or implementing what we thought is the algorithm, right? So this is the example. Okay, so here when we look at the index of, it will be x, it will decrement that x will be corresponding thing in x will be 0 in the character map, and it will decrement to -1, which is fine. It is not greater or equal to 0, and that will not decrement the match count, and that's exactly what we want, right? We don't want match count because x is not one of the characters in T, so we don't want the remaining match count to be one less. So this skips that, it will skip that for y, it will skip that for z, it will come to a finally. At that point, it is going to decrement. Remember, a's count is 1 in the array, right? It will decrement that to 0, and it is greater or equal to 0 after decrementing, and it is going to decrement the match count, which remaining match count, and that makes sense. But remaining match count is 2 because it started with 3, right? So it is still not 0. So it's not going to do any of the things in the while loop, which is good, which is what we want. D is fine. It will make that -1. O will be made -1. It will come to B. B will do the same thing. It will reduce B's count from 1 to 0. And it is, since it is 0, we'll decrement remaining match count as well, which makes sense that the remaining characters to match is only 1 because A and B have been seen. And then, but it won't execute the loop. And finally, it will reach C, it will do the same thing. But at this point, the remaining match count does become 0 after decrementing. And since it does become 0 after decrementing, we will run the loop and we'll try to peel off from the left side as much as we can. And this is interesting. I want to actually check that, right? So let's do that. Let's just check this because that is actually an important loop. So one last thing to check and then we'll try to run it. So S is this, and the substring we are considering, which means left is 0 and right is 0, 1, 2, 3, 4, 5, 6, 7, 8. Right is 8. Correct? Yep. And then at that point it says, okay, hey, remaining match count is 0. Yes, it is. So we look at the substring's length. It will come right minus left plus 1. 9. Is that 9 length? 1, 2, 3, 4, 5, 6. Yes, length 9. And it says, yeah, that is a better one than we have found so far. So it will assign that to these two guys. But now it will look at the left character, X. It will increment. Wait, is it incrementing or decrement? I mean, is it decrementing? Oh, this should be incrementing, right? Okay, see, I did find a bug. Yes, it's incrementing because we are removing that from the substring. Yeah. Okay, so we basically look at the left ch index, we look at its count and we increment it by 1 because we have removed that character from the substring. So we do that, but that won't become, well, it does become 0 in this case, does it? No, it doesn't because we got it before we incremented. Okay, so this is confusing and it already confused me once. So I'm not going to do that. I'm actually going to do this because that was really confusing. Okay, so yeah, and in this case, I don't even need that variable. Sorry about that, guys, but I think it's just a little bit easier to read the code with that post increment operator was completely confusing. Oh, wait. Just this much equals 0. Okay, so if the count of that character is already 0, then we increment remaining match, and that's because others will be negative, right? Other characters will be negative at least before we increment them, right? And then we increment the count of those characters, right? Yeah, that makes sense. Okay, I think I'm glad I ran through that. I already found a couple of bugs, and I think at this point it should be good, at least good to run, at least run manually as much as I could. Okay, so while remaining match count equals 0, okay, what is remaining match? Oh, maybe I still have a typo in even declaration. 1 second. Rem match count, no, it is rem match count. Oh, C is small, okay. That's good. Let's look at the next one. Still more compiler errors. Substring. Oh, best left. It's not best left. Oh, min left. Okay. Yeah, I was debating in my head between the names min left and best left, so that's how I got confused. The min length. Okay, so it is going into an infinite loop for some reason. Oh, that's because I think I know. We never incremented, right? We can just do it here after we read it. Yep. Runtime error. Out of bounds for length 13. 1 sec. Am I supposed to do -1? 9 to 14. Oh, because okay, I know why. So I actually incremented right here and then I calculated it here. So I don't need this +1 here. That's the problem. Initially I wasn't incrementing right there, and now, so right will be already incremented and it will be in the index. Yeah, there you go. It will be pointing to the index after the character that we just checked. Okay, so that's cool. Sorry about the bugs there, but I mean, that's what happens when you're live coding and, translating some complicated algorithm into code. Okay, so let's submit this. I'm really nervous about at least the time. and correctness as well. Like, some test cases they run are really long, and not sure if we will succeed. Oh, awesome. That is really cool. I'm very happy with that. Yeah, I mean, that's good. And it is an O of n plus m algorithm because we are basically running a sliding window through S, and that will basically be going through, in the worst case, the linear time in S of length of S, right? So yeah, that is what it is. Again, sorry for a few bugs and kind of going a little bit longer in this video, but I'm glad it actually in the end worked out. Okay, hopefully you're liking what I'm doing on this channel. Please consider subscribing to my channel and hit the like button on the video if you can. I'll see you guys next time.